Okay, so we're still doing Unit 6, Day 4 notes, and now we're on to page 2. And if you look at example 2, you'll see that we can actually factor the denominator of our second fraction. So we take out the greatest common factor, which is x, and we have x times x plus 2. And you'll notice that our first fraction also has an x. So the first fraction is only going to need an x plus 2. So I'm going to have x plus 2 for x plus 2 times 15 over x. So now that fraction's good. The second fraction already has x and x plus 2, so we're going to leave that one alone. And we almost forgot about the right side of our equation. Here's a 9. And it's also going to need an x times x plus 2. So let's write the x and the x plus 2. Okay, all of our denominators are now x times x plus 2, so we're going to deal with only the numerators. And I'm going to distribute my 15 times x and 15 times 2. So I have 15x plus 30. And I still have 9x squared minus 7x. And this is going to equal, I can take the 9x and I can distribute it to the x and the 2. So I'm going to have 9x squared plus 18x. So now I need to make one side 0, so I'm going to subtract from the right 9x squared, and then on the left, and then I'm going to subtract the 18x from one of these. Okay. So now on the left I have 15x plus 30. These canceled out completely. I thought I was going to have a quadratic equation, and I end up with a linear equation, and I have minus 25x equals 0. So I'm going to combine my like terms. 15x and negative 25x makes negative 10x plus 30 equals 0. Subtract the 30. Negative 10x equals negative 30. Divide by negative 10, and I get x equals 3. So now I need to plug this into the denominators. So if I put 3 in for x, I still have not 0, and that's good. And if I put 3 into x plus 2, well, that makes 5, and that's also good. So I have no issues with my answer of x equals 3, so I'll give myself a check. And let's move on to example 3. In example 3, x minus 1 is prime and x plus 1 is prime, but we can factor x squared minus 1. So x squared minus 1 is the difference of squares. We get x minus 1 times x plus 1. So you can see the first fraction has x minus 1, the second fraction has x plus 1, and the third fraction has both of these. So our least common multiple is going to be x minus 1 times x plus 1. So I'm going to multiply the first fraction by what it's missing. It's missing x plus 1. And I'll put parentheses so I remember to FOIL that later. Then I have minus, I have 2x minus 3 times, this fraction is missing x minus 1. So I'm going to multiply it by x minus 1 over x minus 1. And then the last fraction is missing nothing. It has both x minus 1 and x plus 1, so we leave that one be. Now all my denominators are the same, so I drop them, and I'm going to deal with the numerator. So the numerators, I have to FOIL the first one. I have 2x times x and x times 3. So 2x squared plus 3x plus, I've got 2x and plus 3. Don't forget about this minus here. This minus is going to be attached to my answer when I FOIL over here. So 2x squared and minus 2x minus 3x and plus 3. Like this, and this equals 10. So let's see now what I do when I distribute my minus. I have 2x squared. I'll combine these two to make 5x. And then I'm going to use this minus right here, and I'm going to distribute it to everything in the parentheses. So I have minus 2x. This minus 5x here becomes a plus 5x. And then the plus 3 becomes minus 3. Alright, so I'm ending up here with a quadratic equation, and I have to still combine terms. So I still have 2x squared, and I have plus 10x minus 2x is plus 8x, and I have 3 and minus 3, which cancel out. I could subtract the 10 from both sides, and I can get minus 10 equals 0. I'm going to divide everything by 2, divide both sides of my equation here by 2. So I get x squared plus 4x minus 4x. Let's see, let's fix that. Okay, so this over here was a 10. And this is going to be x squared plus 4x minus 5 equals 0. And now I'm going to factor this so that I have x minus 1 times x plus 5 equals 0. And then you set your factors equal to 0. So when I set x minus 1 equal to 0, I get x equals 1. And when I set x plus 5 equal to 0, I get x equals negative 5. And I have two answers here, but I need to check them. When I plug 1 back in to x minus 1, that makes these denominators 0, and that's no good. So I need to get rid of that answer. If I plug negative 5 into my denominators, it's fine, no issues. So my answer is just going to be x equals negative 5. Okay, last problem. My denominators are 3x, and the only term that's missing the 3x is the first term, the 1. So I'm just going to multiply my first term times 3x over 3x. And then I still have x squared minus 5x minus 24 over 3x. And I have x minus 6 over 3x. So now all my denominators are 3x. That was very quick. And now I'll deal with my numerators. My numerators are 3x plus x squared minus 5x minus 24 equals x minus 6. And let's bring all of our terms to the left. Minus x plus 6 plus 6. Okay, so I have 3x plus x squared minus 6x minus 18 equals 0, and I need to combine my like terms still. I have x squared minus 3x minus 18 equals 0. So to factor this, I need two numbers that multiply to negative 18 and add to negative 3. So let's see, we need a 6 and we need a 3, and the 6 is negative and the 3 is positive, and this equals 0. So x minus 6 equals 0 gives me x equals 6, and x plus 3 equals 0 gives me x equals negative 3. And when I plug those into the denominator, neither of them makes the denominator 0. So both of these answers are good. we're all done with that, and then you just want to make sure you try the problems on page 4 of your notes.